Hey there! Thanks for stopping by. Let's dive into something amazing together. Welcome to Next Gen EduBuddies. Don't forget to hit those buttons below to stay connected. Like, comment, subscribe. Let's keep exploring together.
The Earth is observed from space, bathed in sunlight. Sunlight interacts with the Earth's atmosphere, creating a visible halo. The atmosphere's presence is essential for sustaining life on Earth. The global scale of the Earth emphasizes the interconnectedness of its systems. Svante Arrhenius was a pioneering scientist who first considered the heat-trapping properties of the Earth's atmosphere. Arrhenius's work predates widespread concern about climate change. Arrhenius recognized the atmosphere's ability to retain heat. The heat-trapping properties of the atmosphere are fundamental to understanding climate. Arrhenius's early insights laid the groundwork for modern climate science. Understanding the Earth's atmosphere is crucial for addressing climate change. Svante Arrhenius employed experimental methods to investigate the properties and behaviors of atmospheric gases. Early chemistry equipment was used to analyze and measure the composition of air samples. Arrhenius's experiments provided foundational insights into the role of gases in atmospheric processes. The experimental approach involved precise measurements and controlled conditions to ensure accurate results. Arrhenius's 1,896 calculation predicted a significant temperature increase on Earth due to doubled CO2 levels. This early climate science calculation demonstrates the predictive power of scientific models. The calculation underscores the potential impact of increased CO2s on global temperatures. Arrhenius's work laid the foundation for modern climate change research. The correlation between CO2's levels and temperature rise was established through Arrhenius's pioneering work. Early climate models, like Arrhenius's, provided critical insights into potential environmental consequences. The greenhouse effect is a natural process where certain gases trap heat from the sunday. Gases such as carbon dioxide, methane, and water vapor are primary contributors to the greenhouse effect. These gases absorb and re-emit infrared radiation, preventing heat from escaping into space. This process maintains Earth's temperature, making it habitable for life. CO2 molecules absorb infrared radiation, leading to atmospheric heat retention. Infrared radiation excites the vibrational modes within the CO2 molecule. The excited CO2 molecule releases energy as heat, contributing to the greenhouse effect. This absorption and emission process traps heat within the Earth's atmosphere. The molecular structure of CO2 is crucial for its infrared absorption capabilities. Increased CO2 concentration enhances infrared absorption, intensifying the greenhouse effect. Svante Arrhenius connected human activities to potential long-term changes in global climate. Arrhenius's insight highlighted the potential for human actions to influence the Earth's climate system. This connection emphasized the long-term consequences of human behavior on a planetary scale. Arrhenius's work served as an early warning about the impact of greenhouse gas emissions. His research underscored the importance of understanding the complex interactions within the Earth's climate. Arrhenius's insight laid the groundwork for modern climate science and policy. The Industrial Revolution marked a period of significant increase in CO2 emissions. Industrial growth during this era heavily relied on fossil fuels, a primary source of CO2s. Factories emitted large quantities of smoke, visually representing the scale of pollution. The rapid expansion of industries contributed to a dramatic rise in atmospheric carbon dioxide levels. This surge in emissions had significant environmental consequences, impacting air quality and climate. The Industrial Revolution serves as a historical example of the environmental impact of unchecked industrial growth. Modern cities are significant sources of CO2 emissions, contributing to atmospheric greenhouse gas concentrations. The 20th and 21st centuries have seen an amplified release of CO2s due to urbanization and industrial growth. Transportation, power generation, and industrial processes are major contributors to urban CO2 emissions. Urban infrastructure and building operations contribute to CO2's emissions through energy consumption and waste generation. Continued and amplified CO2's release exacerbates climate change and environmental degradation. Rapid industrial growth has significantly amplified CO2's emissions. Increased CO2's emissions are a primary driver of climate change. Climate change is now a pressing global reality. Addressing CO2 emissions is crucial for mitigating the effects of climate change. Melting glaciers serve as a visual representation of the effects of global warming. Increased global temperatures directly contribute to the accelerated melting of glaciers. The melting of glaciers is a tangible impact of rising global temperatures. Glacial meltwater contributes to rising sea levels, impacting coastal regions. The reduction in glacier size affects water resources and ecosystems. Greenhouse gas emissions contribute to the increased frequency and intensity of extreme weather events. Hurricanes, intensified by warmer ocean temperatures, demonstrate one consequence of greenhouse gas emissions. Prolonged droughts, exacerbated by climate change, illustrate another impact of greenhouse gas emissions. The consequences of extreme weather events include environmental damage, economic losses, and displacement of populations. Rising sea levels are primarily caused by global warming and the melting of polar ice. The melting of polar ice directly contributes to increased ocean volume. Thermal expansion of water due to rising temperatures also contributes to rising sea levels. Rising sea levels cause significant environmental disruptions in coastal regions. Coastal erosion, habitat loss, and increased flooding are direct consequences of rising sea levels. Greenhouse gases are scientifically confirmed as the primary driver of global warming. The scientific consensus supports the conclusion that increased greenhouse gas concentrations lead to rising global temperatures. Multiple lines of evidence, including atmospheric measurements and climate models, validate the role of greenhouse gases. The warming effect of greenhouse gases is attributed to their ability to absorb and re-emit infrared radiation. This confirmation reinforces the need for mitigation strategies to reduce greenhouse gas emissions. Greenhouse gases contribute to a global increase in average temperatures. Rising global temperatures lead to more frequent and intense extreme weather events. Environmental disruptions, such as melting glaciers and rising sea levels, are consequences of global warming. Global warming causes widespread environmental changes and ecological imbalances. Svante Arrhenius provided humanity's first glimpse into the climate challenge. Arrhenius's work highlights the importance of early scientific understanding in addressing planetary challenges. Early scientific insights can guide present-day actions to protect the planet. Arrhenius's research serves as a reminder of the long-term consequences of human activity on the environment. Understanding historical scientific contributions is crucial for informed decision-making in environmental protection.
Don't forget to click subscribe and join the family. There's so much more coming your way. Subscribe now and never miss out on the fun.